All right, we're gonna jump in here, start talking more about variables and some more complicated topics. I guess is what I would say about that. So in the previous video, we highlighted how that was the demarcation point. From here on out, we're gonna do a couple things differently. We're gonna talk about concepts that are inherently related or inherently fall under the header of computer science. What does that mean? Well, if you want to be crazy about it, you can see I'm watching my own video here. I have a video window open with my desktop right here, and I minimize that, and then my desktop's there. How meta is that? Funniness aside, gonna go to Wikipedia, which we're using for the series. Go to computer science, type it in. The article is very, very big, and you can see that it links to many, many, many different topics. Some of which are just a category because you can't even fit all the information in an article. If computer science is your thing, that's great. You may not, this will be kind of a might bore you a little bit the next couple videos, but we're going to assume that computer science is not your thing, because if computer science was your thing, you wouldn't need to be watching this to understand how cheat engine works. You could just open up cheat engine, you go to help, you go to cheat engine help. It's got a whole bunch of stuff here. It's great. Say there's a help menu, but the help menu doesn't help me because I want to know about cheat engine and assembly. Well, it does help you. You just didn't dig deep enough. You go to tutorials, open it up, expand it, see ASM and hexing theory. Gives you some basic assembler. What's the difference in byte type? This is, gives you an article, or wouldn't call it an article, but it gives you a little bit of data, which is essentially if you wanted to take, the 5 to 7 videos that I've done about typing, and you wanted to just smash it into as small text as possible, you could probably, this is probably what you'd get. Uh, as I've demonstrated repeatedly in the series, I'm clearly incapable of being concise about what I'm trying to say. Instead, I just talk about totally random shit in a completely random way. Even if I go down here and I type up a plan, I quickly diverge from that plan by minimizing that plan and then launching off into a tangent. And I don't know what to tell you about that. It's just how I do. So anyway, uh, you can see that there are, you go to Cheat Engine, you go to Help. There are tutorials. It gives you some basic stuff, not just on assembly theory and Cheat Engine and code injection is something you might be interested in. You can see allocating memory. What are we labeling that memory? How much are we allocating in bytes? 1024. It's 1 kilobyte. Points to a block of 1024 bytes. It's great. So, I mean, if that's the kind of thing you're interested in, you don't have to listen to me ramble on for the next, 2 hours or however long it takes. You could just go to the help, dig around, see if you can find what you're looking for. And if you can't, then, you go to forums and ask around, whatever. So, again, what we're going to start getting into here is computer science concepts. And if you already have a background in this stuff, I'm not going to I'm not going to make 2 branches of videos where, oh, well, if you have an understanding of computer science, click here. If you don't, then don't click here, click here. It's not something I'm interested in doing, not something I'm going to do. So, where we left off, so I clearly can't type for shit. Let's bring up Cam Studio. Let's see. How long did I take just rambling on about that dumb crap? Almost 4 minutes. How ridiculous is that? That was intended to be 30 seconds, and I spent 4 minutes. So, again, I have a real problem. Variable, we want to talk about variables. Click back here. We want to talk about variables as far as computer science go. We don't, variable in mathematics. You will find essentially that this is as good a spot as any to talk about this. Variables in computer science are, let me be more generic about that. Any concept in computer science is almost immediately related to a concept in mathematics, and as a matter of fact, the concept of computer science is more generally speaking a descendant of what that concept is in mathematics. Computer science is, some people disagree with me on this here. Well, let's go to the article, see what it has to say. Storage location, blah blah blah. Let's go back to the computer science article, and what we will do is we will just search this article for mathematics, see what it has to say. As it became clear that computers could be used for more than just mathematical calculations, the field of computer science broadened to study computation in general. What is computation? Well, we'll click on that article, bring it up. What is computation? According to Wikipedia, computation is any type of calculation or use of computing technology and information processing. Computation is a process following a well-defined model understood and expressed as, for example, an algorithm or a protocol. We talked a little bit about algorithms. Study of computation is paramount to the discipline of computer science. This is where we came from. This is the article we're at. Let's go to information processing. Let's read a little bit about that. What's information processing? Well, according to Wikipedia, information processing is the change or processing of information in any manner detectable by an observer. It's pretty abstract. Let's keep going. As such, it is a process that describes everything that happens in the universe, from the falling of a rock to the printing of a text file from a digital computer system. It's a little more abstract than we might prefer. Let's go down here a little bit, see what the table of contents has to say. Cognitive psychology. It's definitely not something we're gonna jump into here. I was hoping this might be a little more oriented towards computer science, but it's clearly a more abstract thing. So anyway, we'll go back to this article about computation. Computation can be classified three unique criteria: digital versus analog. That's a distinction we're not going to have to deal with in this series, and thank God for that, because it's ridiculous, and I really don't want to talk about that. Now we get into physical phenomenon, purely physical phenomenon, closed systems, universes, physics, things like that. Not really interested. I mean, I'm interested in that, but I'm not going to talk about that. It's what is that? The one thing in the series I'm not going to talk about. Going to mathematical models, the theory of computation. Diversity of mathematical models of computers has been developed. Typical mathematical models of computation or models of computers are the following: state models, the Turing machine, the push-down automaton, the finite state automaton, PRAM. Is that parallel random access machine? Man, that's some acronym. Lambda calculus. If you want to click on that link, you can do it, but I'm not going to do it. It's a whole series of. Let's just say that. So what was the one thing we're not going to talk about? Cognitive psychology. Well, you know what the second thing we're not going to talk about is? Lambda calculus. If that's something you want to find out what that is, you can click on that link, and when your head explodes, you can come back and you can make your own video about lambda calculus, but I'm certainly not going to go in there. Logic programming is a little more abstract. Actor model, process calculi is interesting things. But anyway, basic point we're making here is that computer science involves computation, and it's an approach to computation and how to deal with sort of expressing computation and processes in a coherent way, I guess I would say. Let's see if we can maybe do ourselves a little bit of favor here. Algorithms and data structures. That's probably a little more relevant to what we're going to talk about. Data structures. Yep. Just click that. You know what? We're going to go back. Go to programming language theory. Programming language theory is a branch of computer science. Deals with the design, implementation, analysis, characterization, and classification of programming language and their individual features. See over here, big Greek symbol for lambda. Falls within the discipline of computer science, depending on and affecting mathematics, engineering, linguistics. It's a well-recognized branch. Steam wants to update down here, so I'm going to click that, but I'm going to get rid of that so it doesn't blink. An active research area. Publishes lots of results. We could go on and on and on, but basically, we are going to jump into the topics of computer science that are going to cover pretty much the entire realm here. No, certainly not the entire realm. We're not going to touch on artificial intelligence. Computer graphics and visualization. Probably not going to talk about that. Maybe tangentially, but certainly not in any concrete way. So I know the last video we sort of jumped into it and was like, oh, here's some of the things we're going to talk about, and I'm trying to sort of solidify this a little bit more. What does it mean that we're going to talk about computer science? Well, we're going to talk about things like computation. We're going to talk about things like programming language theory. We're going to talk, computer programming. Click on that. This probably brings up a more general article, software development process. Let's just read a little bit more here. Computer programming's comprehensive process leads from an original formulation of a computing problem to executable programs. Well, let's just take this one sentence right here. What is the executable program? Well, in our case, and in the entire, we'll close that, the entire case of this video series, the computing application or program that we're going to use, cheat engine, attached to a process, search for values. That's the application we're going to use. It provides functionality, provides a way for us to use that functionality, and we're going to use that functionality. What is the problem? The computational or computing problem, to take it lifted verbatim from the article. What is the computing problem that we're trying to solve? Well, in the context of cheat engine, it could be any. It's kind of a dynamic set of problems. We're going to pull this up real quick. What are we at? All right, we got a little time. So, what is the computing problem we're trying to solve? Well, the computing problem that we're trying to solve in our case is finding values or finding pointers or other data type or data structures or whatever you want to say. Finding values in a process in a dynamic way so that we don't have to refilter values every time we load a game or change the state of the application in a way that forces the application to reallocate huge chunks of memory or deallocate existing memory in a non-predictable way. So, what are we talking about? Well, it's again, we've linked it to some process. Who cares what that process is? We're searching for that. Doesn't make any sense because we're typing text into a 4-byte value. It's so it's never going to return sensible results. Let's do 1, 2, 3. Do a first scan, 4 bytes. A couple next scans. Got 58 values. I don't know. Let's scan for 1, 2, 3, 4. See if we get one. We don't. So we'll repeat that first scan 1, 2, 3, 4. Just pick a random value of memory. So what are we talking about here? Well, the computing problem that we're trying to solve is this is the value we want to find as entered in this box here. And we want to find this value relative to a type, in this case 4 bytes, relative to an address, relative to a process. So let's say this in a more general way, in a way that may not make sense, but we're going to go over in the next couple of videos and talk about why it makes sense once we have sort of a foundation in computer science to talk about. So cheat engine, link to a process, Flash player plugin. There's something going on in my browser where it needs Flash. So if I had to guess, it's probably some of the YouTube stuff I have open. Anyway, process associated with the memory space. That much right there is not rocket science. We've already talked about that, so that should make sense to us. What is this address? This address, as we've alluded to, is relative to whatever this value, or to whatever the start of this, to whatever the start of the memory of this process is. So again, as a little recap, Flash Player plugin has a value, or the memory for this process. There's a place where it starts in memory. This value is added to that absolute address, or whatever that memory is for this process. We're interpreting it as this specific type, and this is what the computer is returning. It's returning a bit pattern, or the processor, whatever you want to say. It's returning a bit pattern. This is what that bit pattern means in the context of 4 bytes. If we change it to 2 bytes, it won't change. If we change it to 1 byte, this will absolutely change. You can see it just goes to negative 46. It's wraparound, rolls over, and a bunch of crap like that, which we kind of talked about. So the type, application specific. It's not something we're bound by. This address is allocated and deallocated. Let's bring this up real quick. See if I can jump into this. We got about 90 seconds left. So this address refers to memory that is allocated when the process starts or executes a specific subroutine. And if we force the application to reallocate that memory, this address will, with absolutely no doubt, this address will change. And so to bring this home real quick, what is the computing problem that we're trying to solve? We're trying to solve the computing problem of being able to determine what this address is in a dynamic way so that when this process allocates, reallocates, deallocates, whatever you want to say, chunks of memory, it doesn't matter. We are memory allocation agnostic. How's that for 3 words for you? We'll get into this a little bit more in the next video.